So there we go. So welcome everybody to our special edition of the Alpha Birding Club webinar series. Today we're pleased to have Annabelle Rayson join us today. She's a student at Harvard University and currently at the summer over at the Harvard Forest. And we're just happy to have her tell us about the Plankton Wars. So it's all yours, Annabelle.
Okay, wonderful. I hope everybody can hear me. And thank you so very much for this opportunity, and especially last minute. Well, good evening, everyone. My name is Annabelle Rayson, and I'm entering my second year of studies in environmental sciences and engineering at Harvard. I'm currently a summer student at the Harvard Forest. I'm a proud Canadian and am the winner of the 2022 Stockholm Junior Water Prize. Tonight, I will talk for a little bit about my research, and then I'm hoping for the rest of the evening for us to have questions and conversation. I've always loved learning and asking as many questions as possible. And growing up in beautiful southwestern Ontario, around the Great Lakes, I have a deep love and appreciation for our environment. I'm especially drawn to water, whether it's swimming, kayaking, fishing, a family bonfire at the beach, or a peaceful hike. I've always loved our incredible freshwater ecosystems. As a daughter of a high school and college biology teacher and a commercial fisherman, I was able to learn and ask many questions about freshwater growing up. Naturally, the science fair seemed like an excellent opportunity to ask questions, learn more, and help people in the environment. In fact, helping people in the environment has been the basis for all of my projects. I participated in the Lambton County Science Fair annually since the 4th grade and attended and medaled at my first Canada-wide science fair in the 8th grade. After the science fair pandemic cancellation of 2020, I placed silver at the virtual 2021 Canada-wide science fair for my study on Zooplankton biomanipulation to treat and prevent harmful algae blooms, a severe issue impacting the health and safety, water quality, and economy of my region, as well as my dad's livelihood as a commercial fisherman. In fact, I was so passionate about this problem and so enthralled with the subject of limnology that I continued this research for my grade 11 project, Plankton Wars, an innovative analysis of Daphnia Genotype Biomanipulation for Algae Bloom Prevention. And I am very excited to speak to you about my limnology research today. When you think of freshwater ecosystems, the most powerful and stunning images come to mind of the magnificent North American Great Lakes, which combined contain 1/5 of the world's fresh surface water, provide drinking water to over 80% of Ontarians, and provide vast economic and employment opportunity. Or of other inland freshwater lakes, such as Great Bear Lake, Great Slave Lake, Lake Athabasca, and Lake Winnipeg. Fresh water is a vital yet finite resource that is essential for life and biodiversity. Humans rely on fresh water as a source of drinking water, for recreation and tourism, for agriculture and fishing, and other economic opportunities. And of course, their beauty and wonder cannot be debated. Freshwater ecosystems also support biodiversity and a variety of essential species. However, our freshwater ecosystems and freshwater quality are at risk from harmful algae blooms. Over 300 harmful algae blooms were reported around the world in 2018. Harmful algae blooms destroy water quality, and when they decompose, they absorb excessive amounts of oxygen, causing hypoxia and dead zones in aquatic environments. In fact, algae blooms are one of the main causes of fish kills, and their harmful toxins make water bodies unsafe for recreational use. In communities around Lake Erie, a North American Great Lake significantly impacted by harmful algae blooms, these two factors contribute to an estimated $272 million loss to the Lake Erie economy over a 30-year period if nothing is done to treat and prevent algae blooms. Algae blooms also contaminate and raise costs of drinking water treatment, destroy aquatic ecosystems by blocking out sunlight, causing dead zones and releasing toxins, and cause severe illness and possibly death in humans. The toxins in harmful algae blooms are especially dangerous to young children and the elderly, and harmful algae blooms have significant detrimental effects on First Nation communities and freshwater coastal communities around the world. With climate change increasing precipitation rates, more agricultural runoff and fertilizer will enter aquatic environments, causing increased eutrophication and algae blooms. It is clear that harmful algae blooms are not going away anytime soon, and a method to treat and prevent them is desperately needed. From past research, I've discovered that the tiny but mighty superhero of our story, Daphnia magna, a keystone filter-feeding species of freshwater zooplankton, is the best species of freshwater zooplankton to biomanipulate to treat and prevent harmful algae blooms and save our lakes. However, very little is known about the species' distinct genotypes, which could allow for more effective, successful, and sustainable biomanipulation of species for algae bloom treatment and prevention. In addition, freshwater ecosystems are very dynamic, and there are a variety of environmental factors, which in turn could help or hinder the ability of Daphnia magna to effectively treat and prevent harmful algae blooms. Therefore, here we are. I performed 5 experiments for a total of 195 tests to identify the ideal genotype of Daphnia magna, to biomanipulate to treat and prevent harmful algae blooms, and then tested the chosen genotype in different environmental conditions and toxicities to represent the dynamic freshwater ecosystems, and performed statistical analysis on all my results, which included normality tests and two-way ANOVAs. All experiments were tested on 2 different species of algae, Chlorella fusca, a non-toxic strain of green algae, and Microcystis aeruginosa, a toxic strain of cyanobacteria. I tested these in 3 different algae combinations to test for toxicity. Additionally, the health implications, biomanipulative success, and effectiveness of the selected Daphnia magna genotype from experiment 1 at algae bloom treatment and prevention when exposed to pond mud and naturally occurring aquatic microbes, microplastics, nutrient pollution, and calcium carbonate was tested in the following 4 experiments. In my conclusions, genotype 4 appears to be an excellent candidate of Daphnia magna genotype to biomanipulate to treat and prevent harmful algae blooms, can effectively do this in nutrient and plastic polluted environments, as well as in a variety of levels of algae toxicity, and can have their health and success improved through calcium carbonate and naturally occurring aquatic microbes. The majority of experiments were found to have normal distribution, low standard deviation, and to be statistically significant. By biomanipulating Daphnia magna for algae bloom management, freshwater environments will become safe and accessible for use by the fishing and tourism industries and will help increase their economic value. Will prevent hypoxia, toxins in dead zones, maintaining diverse and healthy ecosystems, will prevent drinking water contamination, and will prevent severe illness and possible death in humans from dangerous toxins. In addition, by studying the different genotypes of Daphnia magna and further analyzing their performance and health metrics, limnologists can gain a better understanding of the genetic variation, fitness, evolution, and adaptation of a keystone freshwater species as our freshwater ecosystems evolve, which can allow for a better understanding of ecosystem health. Biomanipulating Daphnia magna is also a sustainable solution that will prevent exposing lakes to toxic algicides and chemicals, can remove algae blooms before they decompose, which thus prevents hypoxia in dead zones, and uses a natural solution of a native keystone species that is already present in freshwater environments. By discovering the ideal genotype of Daphnia magna to biomanipulate to treat and prevent harmful algae blooms and the environmental conditions in which it is most successful, the future of sustainable algae bloom treatment and prevention is much clearer, which will help to ensure clean water access and healthy lakes for all. I'm hoping to continue my research at university and to eventually have it tested and approved at an experimental lake facility so that it can be implemented as a solution for harmful algae bloom treatment and prevention. And I'm currently working through the publication process. I look forward to learning more about limnology and engaging in other forms of freshwater research. Thank you so very much. I forgot to change the slides. Here are also pictures of my results. So you can specifically see that you can see all the green and algae bloom beforehand in the test tubes. And then you can see afterwards the mass reduction in the algae bloom. All right. Questions, thoughts, opinions, ideas, conversation?
All right. Well, thank you, Annabelle. And one of my first questions actually goes to how you raise the Daphnia and how easy is it to produce enough to make a difference?
Absolutely. So the lovely thing about Daphnia magna is they're actually already mass produced and used in a lot of labs as they're used often for toxicity or medical testing. So essentially you could take like very large fishing vats or rain barrels and you have the Daphnia in and you want to keep basically culturing them and providing them with algae and aeration and making sure to clean and filter through their water and providing them with proper light cycles. And there you go. They reproduce very, very quickly through asexual cloning. So like you blink and all of a sudden there's 10 new ones. And they're also very cheap and affordable to mass produce as well as they're used in many, many medical laboratories, EPA laboratories, and other environmental areas. And then the plan would be if you have a lake, before harmful algae blooms start, you can make sure throughout the year to increase Daphnia levels and also protect and conserve the lake in a way that we can increase our Daphnia levels naturally. Or when a harmful algae bloom does occur, we can go dump in the Daphnia and they can come in acting like little Pac-Man and eat it all up.
George or Paul, do you have a question or a comment? Or
tell me about these genotypes, Annabelle. Are they from? Can you find one genotype, say, in a certain part of the North America and other genotypes in other ecological areas?
Yeah, absolutely. You're pretty much right on the nail there. So the genotypes that I used were actually discovered by evolutionary biologists at the University of Guelph. And they had found these genotypes commonly throughout different areas in the Great Lakes. The four that they are about 39 genotypes total that they had found and were studying within the 5 Great Lakes. But these were the 4 that they found were the most hardy and sustainable and would be good to travel 3 hours from Guelph back to my little small hometown of Sarnia for me to culture, raise, and play with in my basement.
Okay. Interesting.
What kind of genotypes have they found in New England, or has anybody done anything about that?
That is a very, very good question that I have been wondering myself. I've only been living in New England for 1 year. And this is my first time actually now at the Harvard Forest starting to play with streams. Now currently I'm working with macroinvertebrae and I'm investigating the change in streams with the loss in hemlock from the Hemlock-woolly adelgid. So I'm not quite sure which Daphnia genotypes you have out here, but I would absolutely love to learn.
How subject are Daphne to some of the toxins produced by cyanobacteria?
From my research, because I was testing them with the most toxic strain, Microcystis ruginosa, while there was some mortality rates were fairly low and reproduction rates were very high. So I would say they were not very susceptible. They were hardy and strong and really good green algae fighting machines.
Is it feasible to do the genetic manipulations in Daphne strains in order to introduce a higher level of resistance? Because you may have selection going on and want to counter the effect of it.
That is a very good question. So the genotypes I have are naturally occurring. And essentially the way Daphnia reproduction works is because they work typically through asexual cloning, they're all female. But when an ecosystem undergoes a time of stress, they have a hormonal switch and they actually reproduce males, which they then mate with, which then actually leads to the production of eggs. And those eggs can lay dormant in sediment for up to 80 years. And the eggs actually hatch when the ecosystem is back in a state where it's healthy for them, or when all the Daphnia are gone. And that allows for some of your genetic variation. And that's how I have the genotypes that I have. But definitely I could think with ethical, legal, and a proper lab and all the proper permissions one would need, that could probably be investigated. No guarantees it would 100% work. I'm not a geneticist, but I would like to learn. But I feel like with CRISPR technologies and such, it could be a possibility. Again, no 100% guarantee here.
Well, thank you.
I like George's question. My wife Lois and I have property on a pond in Ashburnham, Massachusetts. And we've had some we're in the headwaters of the Nashua River system, fortunately, and we haven't had a lot of problems so far with cyanobacteria, but they have been identified in our pond, and we've seen some little blooms late in the season. So knowing what can be done to curb the what's happening with the warming climate and having cyanobacteria blossoms is certainly important to us. So I'm pleased to hear hear about what you're doing.
Thank you so very much.
Yeah, I concur with that. I know we're having the algae blooms, interfered with swimming during the summer and stuff, and we're closing beaches off and on. So it's we're glad to see that there's at least you're looking into it. We don't have complete answers yet, but hopefully you will in a few years, and that's all good. So I think that's good. So any other questions, Paul, George, or Annabelle? All right. Well, good. I think Annabelle will go ahead and we'll complete our webinar for tonight. And I thank you so much for taking the time to talk to us about all this. So
Thank you.
thank you very much.
Thank you. My absolute pleasure. Have a good evening, everyone.
Good. Thank you, and best of luck to you with these studies you have planned. It's very interesting.
Thank you.
Yes.
Yep, very good.
Thanks, Dave, for hosting
thanks, Dave.
this.
Yeah, all right, well, have a
Thank
great
you.
night, everybody. Enjoy the rest of
Hey.
summer.
And you too.
All right, see you soon.
Bye now.
Bye now.